All right, so good morning. This is Mr. Wong, and this is my Exploring Computer Science class. So folks, please, if you can keep it down, I just want to make sure the recording's good. So Isaiah, please, and anybody else is talking, thank you. Okay, so we're going to go ahead and get started. Excited to have my friend Joe Oswald, who has a PhD from Harvard University in physics. And I've known Joe, I guess, really pretty much my entire adult life, which is kind of weird to think about. So we attended Duke University together. He was in the School of Engineering at Duke. And so for Computer Science Education Week, I was just very interested in having someone that works in the technology field talk to us and just kind of give us some information about what he does. Because I know some of you, even though you're still in high school, some of you maybe head to college soon, you might be interested in a tech career, you might be interested in computer science or engineering. All right. So that's why I have him here to speak with us for Computer Science Education Week. So thank you. All right, I'll go ahead and throw it to you.
All right, thanks, Mr. Wong. Can I? I'll put on my presentation and go to slideshow mode. Is that? Whoops. Let me go to the beginning. Can you hear me all right and see the presentation?
We're good. I was muted.
Okay. So hi, as Mr. Wong said, my name is Joe Oswald. One thing I do work for Google, but I have to say is for my presentation, I'm speaking only for myself. I don't officially represent Google or any other organization. This is just my sharing my particular career and how I got to where I'm am and how I got there and a bit about what I do, but not anything official about Google or Google products or business. So I'm going to start talking a little bit about myself, how I got started in computers and technology, what I studied in college, what I studied after graduating from college and graduate school, a little bit about my work before Google, and some things about my work at Google, and I'll try to talk about how people like myself get hired at Google, the kinds of people that I work with, the kinds of problems we solve, and the kinds of tools that we use, and wrap up with some thoughts, hopefully for you to take away from this presentation. So, as Mr. Wong said, I work in computers and technology. The way I got started a very long time ago, there were a lot of influences from my family and my school, my teachers. But if I had to identify a few of the important ones, I had an uncle who worked as an electrical engineer, and I think he worked with my father to get me an electronic project kit when I was, I think, 6 or 7 years old. And I show a picture of that kind of kit on the slide. And the idea is you could take these wires and connect the various components up to make things like a radio or alarm or a radio transmitter, so your voice could be heard on a radio set. Also, around the time I got to middle school, high school, my mother was going back to school for a computer science degree, so she was learning a lot about computers at that time. But really, when I was around the 6th grade, that's when the Apple II computers were showing up in schools, and so that gives you some idea of how old I am. These are just a couple pictures of it. It's a very famous computer. It wasn't very capable. It had what we called floppy disks. It didn't store a lot of data, but you could program it and do a lot of fun things. And some of the things that I did, really, I read a lot of programming books before getting a computer of my own, and lots of reading books, magazines. One important thing is that at that time, there was no Google. There were no websites. If you wanted to learn about the computer, you had to find a piece of paper with information on it and read it, or you had to play with the computer and discover it on your own. And so to give you an idea of the kind of thing that I was working on, one of the languages we used was called AppleSoft Basic, and I was really interested in making color graphics appear on the television screen. It was really exciting to be able to write some code instructions, and colors would appear on the screen where you asked them to, and you could make various kinds of pictures or patterns, and exciting things happen. And in my school, sort of in a classroom, probably similar to what Mr. Wong has, a few hours a week, I would meet with some students We would talk about the programs and what we had learned to do, and we'd take turns on the computer that was at the school to try to do some things. And I have to admit that large fraction of what we did was things like game level design for a game called Lode Runner, which is a real classic. It does involve puzzle solving, so it wasn't completely non-educational. But we also thought a lot about games, tried to discover how some of the games worked. Spent some time actually trying to take them apart, trying to look at the code and discover how a lot of the details worked on this and other kinds of games. So that was really, the early start. Around that time, that was the first time I was actually paid to program computers, and the application was an honor roll database. And the problem was at this time that the middle school administrators had to calculate based on every student's grades, every quarter, and their average through the year, who would qualified for the honor roll and not. And there was a lot of numbers, and I guess they went through and did it by hand. And my teacher had suggested that I could write a program to run on the Apple II where the administrators could enter student names and their quarterly grades, save them to a disk, and then my program would sort the student names alphabetically and would print out who made the honor roll for a particular quarter. And I remember even at that time I was getting some user interface advice. I was concerned that the program was pretty slow when it had to sort the names. It took several minutes, and the feedback I got from the teacher was that it's okay if it takes several minutes to sort the names. What the user can do, the administrator can take a lunch break, and as long as it beeps when it's finished, they can do other things while the computer is working. And in the end, I did give them this application on a floppy disk, and as I recall, I was paid a small amount of money in the form of a savings bond from my teacher. But that was sort of my first start into actually making computers do something that other people wanted them to do. After high school, I went to college, as Mr. Wong mentioned. I went to Duke University with him. I studied electrical engineering, and my motivation there was to try to discover and understand how the circuits that make up a computer work. And along the way, while learning that, I discovered I was also taking physics courses, and I found that was interesting as well. And at the bottom, to give you sort of an idea of how that motivation worked, I was literally in two classes at the same time, the same period of time. In the electrical engineering class, they introduced a formula trying to describe how a transistor works, how the current through a transistor depends on voltage. And in that formula that they showed us, there was a number, 0.025 in an exponent, and the engineering professor didn't really explain much to it. It was just a number that was in the formula. Everybody wrote it down and learned it. And right around that time, in a physics class that I was taking, the professor mentioned that room temperature is 0.025 measured in a kind of units called electron volts. And so that was really a clue that, by studying physics, you could really get another level, into how the circuits in a computer work. Like not just, how can you use them, but what are the physical principles that allow the elements of computer to work. And so that, got me going in the direction of physics. And along the way, there was a lot of programming that I did to do homework, to do class projects. So it was not just all class learning. I was learning a lot about using computers and programming computers. And in addition to that, I had a part-time job while I was at college. It was during the school term, it was a part-time job, a few hours a week. I also did it pretty much full-time during the summers, and it was to program some computers they had at the University Medical Center. And the software was a system to help doctors plan out radiation treatments for cancer patients. So the anatomy of the patient would be in the computer. They would draw lines on the screen outlining the tumor, and then they would try to plan how to send beams of radiation into the patient to kill the cancer without harming the patient too much. The kind of computer I used was something called a mini supercomputer. I don't know if you've ever heard of a Cray computer. This was much less powerful than a Cray, but it was probably 1/10 the power of a Cray computer, and it cost about 1/100th as much money. And so it was very popular for these kinds of applications. And in particular, it could do 3D graphics at a time, and that was very advanced technology and not something that the computer you get at home or could hold in your hand can do like today. But some of the main things I learned there is I learned to work on programs that other people had written, and I needed to change them to do something new or better. I learned how to read journal papers which describe algorithms solving abstract problems and turn that into code in this program to do useful things like show pretty pictures. And so I could take some of the lines that the doctors had drawn to identify the anatomy and turn that into a 3D wireframe that could be shown on the screen in 3 dimensions and make a realistic model of the patient anatomy. After I finished college, I continued on to graduate school to get a PhD, a doctorate in experimental physics. Some of the things I learned, the basic idea behind graduate school is that you learn how to make a very tiny but new contribution to scientific knowledge. There are tens of thousands of scientists working today in the field of physics. Each one of them is adding something new to the body of scientific knowledge, and that's what I had to do to get a PhD. To the outside observer, the physics experiments I did looked a lot like plumbing. So we used a lot of plumbing to manipulate, to control tiny electronic circuits, to cool them down to very low temperatures, very near absolute zero, and to shine very short laser pulses onto these electronic circuits, trying to observe and see and understand how electrons behave in those circuits. That project ended up not working out very well, and my advisor for that project ended up changing fields, and I had to switch projects. And the project that eventually got me my PhD was the question is whether we can make certain kinds of optical coatings with very tiny medical particles in them. And so these are coatings that you might, for instance, put on a window, and the window would allow sunlight through, but would block or reflect infrared radiation so that heat inside the room or outside the room would not get through the window, but light would be able to transfer through them. And the answer is yes, you can do that. And my thesis is several hundred pages describing what kinds of optical coatings and how you think about making these optical coatings and so forth. And in this, there was a lot of programming to calculate how these things should behave, both the very tiny electronic circuits and the optical coatings. And so it's a combination of math and science, things like quantum mechanics and optics, electricity and magnetism, and being able to use programs to compute how they behave. But really, it's not just the science and math and the computers. One of the main things you have to learn how to do is to read what other people have done and to be able to talk and present those results and your own results to others so that they understand them and can use them to inform their own research and efforts. After graduate school, I got a job at a company called Teradyne. It's a company near Boston. At the time I worked there, their headquarters were right next to Chinatown, so it was a great place to work and get lunch during the lunch break. And the way I would summarize it is that Teradyne makes roughly $1 million machines which are used to test whether microchips work properly. So essentially every new chip, for instance, in your iPhone or your cellular phone, there are dozens of chips in there. And every one of them has to be tested to make sure it works after it is made. And every new chip that Apple or some other company wants to put into a phone needs to be tested with one of these machines. And you need a program to tell the machine what the chip should do. And so my job was to help companies learn how to write the programs they need to use these machines, help these companies learn how to make very good measurements for wireless communications. So the way that cell phones or Bluetooth devices or wireless network devices communicate, they transmit electromagnetic radiation, which we call radio waves, and to understand how those are produced and can be measured in order to know that they're working properly, that your cell phone will be able to make a call. I also had to help Teradyne understand what kind of instruments the customers need. For these devices, what sort of measurements need to be made? How can those measurements be made efficiently and accurately? And part of that was also helping Teradyne sell the instruments to customers by explaining to customers why the instruments we had were the ones that they needed. So I could help them. They understood about their computer chips, and I could help them understand how they would be tested and why the Teradyne instrument was a good way to test them. This involved lots of programming and understanding technology, but hopefully the other thing I'm able to get across is that there was a lot of communication. There was a lot of trying to understand what other people needed or wanted or were able to do, and be able to explain what we had and the problems we could solve in ways that they would understand and be persuaded that we did understand them and that we had a good solution for them. After about 7 years at Teradyne, for family reasons, I had to work in Manhattan. And the bad news is that there are essentially no microchip manufacturers in New York City. If there were, I would be working with them. But I had enough programming knowledge and enough understanding of algorithms from my past work that I was able to pass the coding interview. And if I had to describe it, I would say that crack the coding interview is a good introduction and gives some idea about what the process is like. Essentially, people try to ask programming questions that you can, answer in 45 minutes or an hour, and be able to give the interviewer some idea that you know how to get problems solved with a computer. In terms of who I work with at Google, one thing that's important to keep in mind is that Google is mostly a company to sell ads. And there are a lot of people who work on selling to advertisers. And I really don't work with those people. I'm pretty distant from that, the part of Google that actually makes the money. But in order to attract advertisers and users, we develop a lot of systems to organize information that people want to have and to make it useful, and also decide how to show them ads associated with this. And in the end, this requires a lot of code, literally billions of lines of code in dozens of different computer languages. There are tens of thousands of software developers around the world who've been working for many years to develop this code. And I give a link there to an article that describes some of the scale, how large these systems are. And if I had to give a typical description of a software engineer, the typical software engineer probably has a master's degree or a PhD in computer science from a top program in computer science. I don't quite fit that mold, but I do have a PhD and do know something about computers. And like I said, I was able to get through the interview process. And in terms of the kind of work I do, I work on Google Maps. Google collects information about businesses and other places or things on the map, and it maintains a very large database of that information. We literally have information about billions of different things like roads, addresses, businesses, bodies of water, mountains, states, cities, zip codes, time zones, and on and on and on. This database is constantly being updated and expanded, both because we get more information about the world, and also the world itself changes. Businesses start, businesses close, businesses move. New buildings and roads are constructed every day, and we have to discover them and put them on the map. And so there's a lot of effort and systems and software engineers who are working on maintaining that database. For the first 7 years that I worked at Google, I worked to fight what we called map spam. And the problem that I had was that when you gather this information, particularly business information, there are people out there who will give fraudulent or misleading business information for a lot of different reasons. But I had to help develop systems to detect and remove that data so that it didn't show up for users, so that users of Google Maps would get accurate information, that they wouldn't be misled or defrauded because of something they read on Google Maps. A large part of that was involving humans who were involved in identifying fraud. So they would look at businesses that they would find on the map and would be able to identify, for one reason or another, they believed the business information was inaccurate or fraudulent. And as humans would do that, we would also try to get computers to automatically identify those common patterns and remove it automatically without having to have a human act on every one of the bad pieces of data, because there was just a lot of it. For billions of things on the map, you can't really have a human examine every one of them individually. And that's a common theme at Google, that there's just so much data that we need to use computers to make sense out of it. After about 7 years, because of a team reorganization, I had to change projects. And my current project is to make the data that we have on the map accessible to other Google engineers and analysts at Google, and to use within Google products in ways that are easier to process and understand. So for instance, if someone had the question, they wanted to know a list of all businesses that are within a kilometer of the Eiffel Tower and are restaurants and are open at 10:30 a.m. Monday Paris time, our system allows them to create what we call a query, and that is a instruction to the computer where it selects the name and identifier of businesses from this database, and the where clause describes how that data is selected. And so it will look at the opening hours of the business. It will look at the kind of business, that it's a type restaurant, and its distance from some location to the Eiffel Tower, which we know because it's in the database. And the result of executing a query like this will be a list of businesses, maybe 10 or 100 or 1,000 businesses that meet these criteria. And then that can be used in some Google product or to do an analysis to see how many restaurants there are. Some of the tools that I use, the main thing is that Google has thousands and thousands of computers. I don't really know if we're up to the millions, but we're pretty close to it. And all of those computers stand ready to run programs for me and for other Google engineers and Google systems. And a way to understand this is that there are products that we call things like Google Cloud. Amazon has Amazon Web Services, where these thousands of computers are made available to end users. Most of those users have to pay for the privilege, but I can use it almost without thinking about it. It's really like going to the sink and turning on the tap, and water comes out. And behind that, there are pipes and dams and reservoirs, thousands of miles away. But it all shows up at the tap, and I don't even have to think about it. I just ask for 10,000 computers to work on my program, and they work on it. We have large what I would call query systems, which can figure out how to translate that query that I showed you on the previous page, how that can be actually computed, what files need to be read, and how those files can be scanned efficiently for data that matches the criteria. And so I develop systems that try to take our maps data and organize it so that it can use these query systems to answer questions that analysts and other users have. The data has to work well with query systems, so I have to understand how the query systems work and what they are good at, and to organize the data so that these queries can be fulfilled quickly and efficiently. So I have to understand what the systems are good at. I have to understand what users really want to know, and how to find a solution using these systems that works in both senses of both ends of that problem. And that involves lots of communication with our users and with the experts who work on the query systems to understand their problems and how they can be solved. One of the other things that I'll mention, because it's a very common theme at Google and elsewhere, is something called machine learning. And the way I understand it, I'm not an expert in machine learning, but I use it from time to time. It's essentially a way to process very large amounts of data to identify patterns. And in the corner, I show a picture. You probably have seen how you can take a very small amount of data and use a computer or a calculator to find a line that will describe the pattern of data. And that's a very simple computation, but machine learning is really just that applied at a much larger scale. So it's not magic, but if you have thousands of computers available, or very powerful computers that are specialized for this kind of data processing, you can test for lots of different patterns in huge amounts of data, more data than a human can really understand at one time. So for the map spam problem, one of the things that we try to do is have a computer identify what words in a business description make it likely that the business is fraudulent. In order to make this decision, a computer doesn't really understand fraud, so we need some number of human decisions to train the computer, that a human will mark a few hundred or maybe 1,000 things. This business is fraudulent, this one is not fraudulent. And if you do that enough times, the computer might be able to identify some pattern that predicts what the human decision will be, and then it can turn that into an automatic decision to not have to involve the human in the future. And computers can also identify patterns based on some unusual combinations. So there's some very rare phenomenon, some pattern that we might call X and some other pattern Y. Both of them are very rare, but they happen together at the same time much more than you might expect by chance. And so those patterns may be a very useful sign that something is going on, that there's something about the world or the data that is interesting, and a human might be able to look at it and understand something about the data. A very important thing is that these patterns can sometimes be mistakes or random, or even introduced by human bias. If there's something about the human decision that is training the computer that is biased, then the computer will recognize that bias and will try to apply it itself. It really does not understand, in a human sense, what it's doing. It's just trying to identify patterns, match them to some criterion that you've assigned it, and it's only as good as that human definition of the problem is. So hopefully, I've given you an idea that Google is an exciting place to work, and some of the nice things about it are there are many, many great software developers that I get to work with. There's an enormous amount of machines and powerful software that's available to solve my problems. And one thing is that people around the world use Google Maps and other Google products, and that really is a good feeling that you can talk to people about working for Google, and almost everybody can say, "Oh, I use Google all the time," or "Oh, it's so handy to be able to use it to get to where I want to go or discover things on the map." And that's really a good feeling to know that you're making at least a small difference in the lives of people in the real world. In order to get to where I am, there's been lots to learn, and I've had to change what I'm doing several times. But one thing that's been consistent is that it's not just about understanding the computers or the software or the programming languages or the math or the science. A lot of it is about reading, writing, and communication, and understanding, from a personal point of view, from a human point of view, what it is that people want and need and can do, and not just the computers, but to be able to understand how we can use computers to solve the problems that actual humans have. So that's about all I have. I'd like to thank you for your attention, and I guess we'll move out to questions. I have the questions that Mr. Wong gave to me earlier. I don't know if you want to have the students ask them in person.
Yep. Thank you very much. So that was very informative. Thank you for that presentation.
Sure.
So unfortunately, Kenny, who I think asked the first question, went to the bathroom. So I'll go ahead and ask that first question for him.
Okay.
Actually, well, we'll do it in the order that you have here in the slide. So, and I guess you kind of put them together. So let's see. I think Jack was the one that asked, "What does a programmer or engineer do at Google?" So let me see if I can train the camera towards Jack. Give me 1 second here. All right, let me switch my video. Jack. So I don't know if Joe will be able to hear you, but do you want to just go ahead and ask your question? Oops, sorry. So this is Jack Savaris, and I don't know if I've got Jack on camera or not. So it's number one. I think you asked, what does a programmer or engineer do at Google, and what is it like to work for Google? So.
What does a programmer or engineer do at Google?
Well, it's hard to summarize, but hopefully I've given you some idea. We really use your computers and program them in ways that involve lots of different computer languages. So some engineers at Google use JavaScript. Some people use Java. I use C++ and that language SQL that I showed a little bit of today. But we're able to use these, really hundreds of thousands of computers in order to solve problems. And so a lot of what we have to do is to understand the problems, understand what kind of data we have, and the kind of questions that people have or want to answer, and how to process and organize the data, to discover patterns in the data, and to make those available to our users. And so software that can run websites where people can enter search terms, and we identify very rapidly, data that we have that's interesting to those users. And so hopefully, and a lot of what we do is to talk with other programmers and engineers and really try to collaborate and work together, because no one of us can really solve any of these problems. These problems are much larger than any one engineer, and so we do have I work with 5 or 6 engineers on a daily basis within groups that are tens or hundreds of engineers, and I have to be able to reach out to engineers in lots of different parts of the organization. So hopefully that, I don't know if that is an effective answer, but hopefully that gives you some idea in addition to the presentation.
Great. Okay, and then I think the next question was Manahil. So sorry, I don't know if there's a faster way for me to switch the camera, but okay, so this is Manahil, and so I think you asked the second question here.
Have you ever felt proud of yourself for your work in Google?
I have to say I have. It's what I do is a very small part of Google, but because I know that people use Google Maps and other Google products, I know that I'm able to make um, you know data available to people to use in lots of different ways. And particularly when I was working on map spam, I knew that when I removed bad data, I was making sure that people in lots of countries around the world were getting accurate business information and not being misled, and helping them, have a product that helped them get through their daily lives. And so that is a real good feeling to know that you've helped make that happen. Um, Not everything that Google does is successful or really great, but we all do our best to try to make good products that help people, and that's a good feeling. I think that is something that I feel at least a little bit proud of.
Great. All right. So we're going to go back to Manahil. I think she asked this other question too. So, oops, sorry. We got a video. All right. So another question from her, which was the third one.
Do you use all the Google apps and do you use them in your work?
I probably don't use all the Google apps. There are a lot of them, and some of which I don't even know about. But one of the things that we do in the industry, we call it eating our own dog food. So, we make the dog food, but we also eat it. And so, really, every day I'm using products like Gmail or Meet, like we're doing now. So, particularly in this era of remote working, I spend a lot of time on my video camera talking to other Google engineers in meetings just like this one, presenting information like this. And so using Google Docs and Google Meet and Google Calendar to schedule these meetings with one another, and Google Mail to communicate with one another and keep track of the work that we're doing. And Google has also developed dozens of applications that we use internally. So things like Google Apps, but that are only used. So we have, when we find problems with the software or there are things that need to be fixed, we record it in an internal database developed by other Googlers that we can use to search for these issues and keep track of the work that we're doing to make sure that we're solving the problems that need to be solved. So hopefully that gives you some idea. I don't use Google Maps every day at work. I actually use internal things. I spend a lot more time reading Maps data, using some of our internal things that show us, the very precise details of the maps that aren't visible to end users, but are used to help create the maps.
Great. All right. So the next question was actually mine. So not asking for myself personally, but asking for the students, because I'm hoping maybe somewhere in this group we'll have a PhD, maybe multiple PhDs. But how hard is it to get a PhD?
I think that's a good question. There's a lot of parts to it. One is that it is school, so you have to get there through good grades and good studying. I had to learn a lot in school in order to just get into graduate school. Had to know a lot of science because everybody who showed up there had done the same thing I had, who had a lot of class learning and understanding of the math and the science, a lot of the science that we were doing. And we were all there to learn more. So there had to be, you had about 2 years of the PhD process was doing even more classwork to really learn the specialized knowledge, the advanced knowledge, to really get to the boundaries of what we know in the field. The other thing was to work with a team. I was doing experimental work, so we had other people helping us construct the experimental apparatus. I had what's called an advisor who worked with myself and other students, really like a personal teacher who was guiding us through that work and helping us come up with problems to work on and figure out how to achieve them. It requires a lot of work. Not all of it is hard. A lot of it is just persistence and being able to pay attention to a problem for a very long time, even when it gets boring or stale, to continue until you get through to the end. But it's something that really, if you're admitted to the graduate school, they have pretty high confidence that you can do it. And if you focus on that goal and you really work very diligently on getting that project done, it's something that it really is more about hard work than about any kind of mystical skill or ability.
All right, great. Okay, so I think Tristan was the next question. See if I can put the camera on him. All right, so Tristan, you had question number 5. If you want to just turn around real quick. So it's how much do you get paid?
Well, that's a question that my personal upbringing is that it's not the kind of detail that I share with other people. So I'm not going to answer that question. There are good reasons and bad reasons, I think, to hide that kind of information. There are things about fairness that within the organization, I certainly wouldn't want other people to get paid more or less than me, although that's possible and maybe happening. But it's just not the kind of thing I feel comfortable sharing about myself. But I will say that there are sites like Glassdoor.com that gather information about this. There are salary surveys that are done by organizations like the American Physical Society, the Institute for Electronic and Electrical Engineers, which are the professional organizations in these fields, and they gather data on people who have engineering degrees, people who have physics degrees, how much money they make at what stage of their career. Because that is something that, when you start out, you make, usually a comfortable amount of money, but as you progress through the career, as you get more experience, for me, having a PhD, creates a slight increment on the salary, and the performance, in the job determines how much your manager wants to, give you rewards like stock bonuses, and stock grants. So your performance is part of the combination that goes in there. So that there's a lot of factors that go into it. Those websites that I mentioned, is information there about what engineers in different fields make, and I do not make substantially more than those surveys indicate. So I'm not like Mark Zuckerberg. Is very rich not because he worked at Facebook, but because he founded it. And I'm not one of the people who founded Google. I'm not that kind of. I'm just an ordinary software developer who works for money.
All right, we'll definitely do our research on that later from those sites, and they'll be able to get an idea. But I think I've mentioned to the class that it's not unheard of to be close to 6 figures, or well over, if software engineering is what you want to get into in the future. So okay, so Kenny's back, and I think he was the one that asked that last question. I'll see if folks have other questions too. Let's see if I can get the camera in the back here. All right, so Kenny had a question. He's back in the corner there, and it was number 6.
So how often does the Google card go around?
Well, there's no one answer to that question. I guess the first thing I should say is that I don't really work directly with that team. There is obviously a team of many engineers who are developing, the hardware, the cameras, and so on that go into the cars, so that they can keep track as they're moving down the street. They keep track of precisely where they are, and when they take that picture and record it, they're able to then relate it to a physical location in the world. And there's a lot of science and technology that goes into that. In terms of one of the things they do is try to understand on the map what information do we already have, and how frequently is it changing, and how important is it to users. So we try to prioritize places that people are interested in, places that we don't have information in. So if there's a country in particular where we don't have data, we have to work with the local authorities. Not every country allows you to drive a camera around and take pictures of things on the street. People are concerned about privacy, and there's a lot of cases where we capture pictures of people walking down the street, and we have to, in order to get permission in some countries, we have to make sure that the faces of these people are obscured, and so you can't find that kind of private information for people. But like I said, we look at where is the information needed, how up to date is it, and how frequently is it changing. Is it a place where there's a lot of construction going on? We can detect that. We can see construction equipment. We can see that things are different than the last time we drove down this street. And so that all together, we can take, because it costs a lot of money to actually have someone drive these cars. The cars are expensive. We don't have an unlimited number of cars. So there's a certain amount of expense, and we try to find the highest priority, the best places to send the cars, to get information that will help us create a better map, with the money that we spend. So I hope that answers the question, at least to some degree.
Yeah, thank you. I think it does. And I think, Kenny, there's probably like other articles where people have sort of, either speculated or gathered some data on that. So,
Yeah,
okay.
you can
So,
look on Google Maps. There are places when you look at the street view, there is in some cases a historical view, so you can look back and see what the previous versions of the street view camera saw, and so you can see even on the map that there are multiple versions of the data and get some idea of how far apart they're taken.
right. Great. Thanks. All right. So I think that's the end of the questions that we had prepared for Joe. Does anybody have any other questions for him that weren't in our questions here? No other questions? Okay. All right. So I just want to thank you for the time that you took to make the presentation and the time that you took to answer questions and just talk to us. So, I hope it was valuable for you all. Again, not all of you will necessarily go into a tech field or computer science or engineering or physics or STEM field, I should say. But I thought it would be a good opportunity for you to talk to Joe so that you could get an idea of sort of what that world is like. So, okay. All right. So, again, thank you so much. We really appreciate it. And hopefully I will see you in the family, or my family will see your family in New York at some point in the near future. So thanks again for taking the time to do this. All right.
Well, thanks everybody for your attention and for the opportunity to speak to you, and hope it was helpful and informative. All right. So enjoy the rest of your day.
Thanks a lot. All right.
Take-
I'll go ahead and stop the recording now. Okay. Thanks again. I'll take care. All right.
All right. See you around.
Thanks. Bye.